Hello, everybody. How are we all doing? Let's just do a bit of a check-in. It's 4:20 in the afternoon. Raise your hand if you're a little sleepy. There's been a lot of peopling. We haven't done this in a while. I'm definitely feeling out of practice. I'm just going to let you on a couple of fun facts before I get into this. Firstly, there's a button here in front of me that I'm not allowed to touch that's labeled lift at one end and grind at the other. And I'm not saying if it all goes wrong that we could entertain ourselves, but, you know, buttons there. I'm also not allowed to stray outside the box. So your job is, if you see me wandering off, to say, Laura, no, please stop. So it's lovely to see you all. And it's especially lovely to see you all because you have a choice in this slot. Last time we saw each other, you didn't. It was me and you were trapped. And this time you chose to come here, and that's kind of nice. And there's some great talks in this slot too. So if you were expecting a dude, I'm not the speaker you're looking for. He's probably in 1 or 2 or somewhere else. We're here now to do something a bit more practical in security. So in the keynote yesterday, it was that grand vision. How does security work? How can we think about a future problem? Now, in this talk today, what I want to do is be a lot more practical. So what I want to do is give you some things that you can do today, right now. Well, not right now, because that would be a bit weird. But, you know, in the next few days to do some security in your world. But before I get started, I need to know a little bit about who you lot are. Please raise your hand if you write code every day. That's your job. Raise your hand if you are a security person entitled in some way. Ooh, you're not sure. Okay, you've got to the end of the talk to check on LinkedIn. That'll tell us. We'll know. We'll come back to you. Any of you testers? No? Any of you in leadership and once remember doing coding? Hey, I see you. All right, good. Okay, that helps me understand the room. And actually, it's kind of what I was expecting, given NDC, right? As a developers conference. The thing is that when it comes to security, as in my keynote, it's not about the security people who aren't here. It's about us. The code, the quality of it, that lies in our hands. Now, I'm still Laura. I still did some stuff. A lot of what I am going to talk about today is the type of things that I wrote about in books. Now, please don't go buy the books, but go to use your local library. My mum is very proud. I make no money off them. But if you find copies somewhere, there is a free Russian copy somewhere floating around the community. So do go get stuck in. So I'm telling you this because at the end of this, you might have more questions. And that's okay. That's normal. Please do reach out. Please check the book. Please, use the social media. And given the time of day, this talk might run a little bit short. And at the end, ask your questions. And please don't be that person who's like, I'm not going to ask that question because it's so totally obvious and everyone's already doing this. I absolutely promise you they're not. Raise your hand if you think your team is doing enough security right now when it comes to software. Good. Well done, team. Raise your hand if security is painful and hard and you have no idea where to begin and you're not entirely sure you even want to start down this path. I love a good, honest answer. Fabulous. The honest truth, ugly as it is better than a pretty lie. Just to remind us and make it okay, for those who haven't watched the keynote yesterday, most of us are here at the bottom, at the emerging stage. And that's the polite way of saying I don't do it. And you can't make me. Very few organizations are at the top, and those tend to be not just big organizations, but the type of organizations who build their own tools for things. So when you go to conferences and there's a speaker from Netflix or wherever, it's amazing, but also it's such a weird context that they're doing their thing in. It's kind of like, any of you been React developers? Yeah, sorry. I did it once. I've reformed. But when I first started, and when React first came out, well, it was released by teams who were used to scaling for 10,000 requests a second. These were huge applications it was originally built for. And then I came along with my little open source project, and I'm like, yeah, React is the framework I'm supposed to do now. Yes, I'm going to learn this. And what I found was all of these patterns and all of these instructions and guides were built for a scale of organization that I didn't have. I didn't understand the abstractions and the patterns and the architectures it needed me to do. And so this very complex thing was too much for me. Security is just the same way. You need just the right amount of security for where your company is at right now. There's no 100% security. In fact, it sounds like nihilism. You're screwed. Every single one of us is. The likelihood is you will be breached. It's sad, but it's kind of freeing when you look at that. Every day this week, I've looked at the news, and every day this week, there has been another Australian company that's been breached. Today, it was a medical one. It's not their fault. It's just not our time yet. So what I'm doing in this talk and in any talk you see me in is trying to give you some of the things you need to think about to delay the time that it's yours, or to make sure that if it is, sadly, the time where your organization has more security scrutiny than it has done before, that you have some idea on how to respond to that, how to reduce the impact, make it less of a terrible day. Now, most of us, when we view the world, myself included, we have a little bit of a problem with perception. We tend to think that our code is the center of the universe. Now, this isn't a repeat of yesterday. I'm not saying that your code, as in your entire ecosystem, is part of a giant spiraling network of things and you should feel bad. That's still true. Watch the keynote. But we tend to focus on the code. The code, the code, the code. In fact, in our software development lifecycle, even though we all admit we have a software development lifecycle and it has a few stages and they repeat in a nice lifecycle-y sort of way, we don't talk about secure development much, really. In fact, I went and looked at marketing tools because that's sort of my weird world now. And I wanted to know, what are the key words people look for when they're looking for help writing secure software? It's not secure software. It's secure code. How do I code securely? How do I code in X language securely? Almost 90% of all of the searches that happen in security say code in them, because that's where we focus our attention. It's not the Earth that's at the center of the universe, it's our code. Now, I'm not in any way saying code isn't important. Well, it is, obviously. There wouldn't be software without code. However, does code get made in isolation? Nah. If you're the type of team who's still kind of just rocking up to work going, would it be fun to build today? We'll just code some stuff. That's awesome, but highly unusual. If you came to Brenton's talk before mine and you talked about Agile and where Agile isn't chaos, it isn't just doing whatever and winging it, it has to have some structure. Well, that structure is our SDLC. I don't care if you're DevOps, I don't care if you're Agile, I don't care if you are triple reverse waterfall. It's fine, so long as we remember it's not just code. Because our security approach right now is, and this is a literal quote from organizations I've worked with, hey, it's all right, we've got this. We hire really good developers. Fabulous. How many of you have done any security education as part of being a developer? I trained a few of you, so hi, nice to see you. How many of you just instinctively know how to do security? Fabulous. Great. Guy at the front is now definitely a security dude, and if he isn't on his LinkedIn by the end of this, he will be. I'll make sure of it. We have this assumption that somehow we will implicitly or intrinsically learn how to do this, and this is not something you can naturally do. The instinct to destroy things and to cause chaos and to play and experiment, those skill sets that make you very good in the adversarial security space are not actually naturally found in our engineering space. You're here because you like to solve problems and fix things and put them together and make them work better, not destroy them. So what we need to do is we need to have less of a focus on secure code and more on secure development. Because it's not just our SDLC, it turns out. There's got a bit of a blind spot. And it has to do with who's in this room as well. I remember I asked you about what your job titles were. Does anyone remember that quote? Some dude, some famous dude said it once at some conference. He went, developers, developers, developers. And like Oprah happened or something, I don't know. Things happened and it had developers a lot in it. Like Shakespeare, lots of repetition. And this is how we focus a lot of our rhetoric around security. It's the developers are going to do it. I'm going to shift left security and I'm going to give it to you Fabulous. Now, how many of you have spare hours in your day right now because your workloads are super light? Well, so if I gave you all of the things I needed to do in my job and I said they're now your problem, are you going to be very, very happy with this? No. And are developers the only people on your team? Well, probably not. I know there's less QAs than there's ever been before, but there are definitely other roles. You see, at the moment, we have a blind spot right in the middle of our SDLC. It says that the only people who are going to save the day are you lot, developers, and you're going to do it instinctively with code. So fabulous, good luck. That's the end of the talk. Great, but it's not really, is it? Because saying that developers are going to do it just at code is like saying I'm going to use 20% of the time I have available when building software to do the security. Saying only developers are going to do it says that I'm only going to use, 1 out of 7 different roles are going to have to get involved with this. Doesn't work. So in this, I'm going to give you some really practical steps, literal practical things you can go and run away and do to put something through your whole life cycle. And I'm going to say your whole life cycle and your whole team. So I don't want us to talk about secure developers. I want us to secure development. I want us to talk about development teams doing security, not each and every one of us on our own. Right, so we're going to start off with some design. So we're at the start of our software development lifecycle. Right, this is a part where you gloriously document so many requirements, and they're all super accurate, and you put acceptance criteria neatly on every one. We're all good at this bit, right? We've got this bit sorted, so I can build on that foundation. Well, there's a slight joke in there, and I know that that's not true. Any of you still at the Post-it notes on a whiteboard stage and hoping you remember what the requirement was? Yep, it's all right. No shame of the dude at the back that's honest. Or you've got JIRA items, and it's a title. Yep, there we go. That's the modern whiteboard. I'm just saying that's whiteboard for a remote team. So we're going to do a bit more than that. As of today, you are now a security architect. So congratulations. Yes, there we go. Now, some organizations will have specific security architects, people who have formalized qualifications in, and there are entire career streams in this. But what I'm going to say is, for our intents and purposes, any of you, anyone on your team can be a security architect, because what it means is the person who designs a system and supervises its implementation to ensure that it's safe and high quality and fit for purpose. And that's what you do anyway. You're already an architect without even realizing you were. And we need it because our systems do not look like that. They don't look like neat boxes with one border around the outside that you can protect. They may have done once. Back when I wrote taxation systems, it was one system on one server in one building that was available from 9 till 5, Monday to Friday. That was it. But now our systems are distributed and they're fragmented, and they're made up of lots and lots of components. And so architecture isn't about creating the perfect single building in software. It's about creating an entire city. It's about understanding how all of those parts fit together and what they need to be happy and healthy. Architecture is about understanding what is valuable and precious and vulnerable, and understanding what could possibly go wrong. So if I put, a valuable thing, we'll say, in a cliched term, it's a jar of honey, and we'll choose a bear as our attacker. Why not? And we'll put that where the camera is, straight over there. Now, I want you to imagine that a big brown bear comes through that conference door there. Fantastic. Now, tell me about the bear. Does anyone want to shout out a characteristic of our bear right now? Brown. Fabulous. We're doing well. It's your enthusiasm that's it's bowling me over. Hungry, yes, because this bear's very lost. Bears do not belong in central Sydney. Least of all do they belong in the Sydney Hilton at 4:34 in the afternoon, having come up several sets of stairs, escalators, or a lift. This bear is not just hungry, he's fairly confused and probably a little bit upset. And if we have something in the middle of the room, say a tub of honey, well, because it's politer than saying your internal organs, over there as a snack box, then that attacker, that threat actor, they're going to be motivation-driven, they're objective-driven to get to what they desire, which at this point is a snack, and to feel less scared and afraid and confused. As architects, our job is to understand in our system what is the honey and what is the bear. And it's different every time. And then it's to decide what boundaries, what checks we put in between the bad thing and the thing that we value. So in the case of our bear, we could put bear traps across the floor. I mean, is it particularly a nice thing to do? No, but it's a fictional bear, so we'll be fine. The problem with bear traps is, well, how many bear traps would you need to cover the floor? Quite a few, I'd imagine. And then how are any of you going to get out of the room? I feel like that might not be the best security control for us right now. So we could look at other security controls. We could look at cameras. Well, is that going to stop our bear? Well, no. But it's what we call a detective control. It's going to help us tell that the bear has arrived and a bad thing is happening. So we can do what? Well, we can respond. And what do you do in response when a bear is in the conference room with you on the 3rd floor of the Hilton? Put it onto YouTube. So he's volunteering as distraction for all of us. The rest of you, those with survival instinct, what are you doing?
Lie down.
Lying down. Play dead? Yep, absolutely. Yeah? Green sign. It's not covered in the safety manuals, but absolutely, calmly, make your way to the green sign. Don't die via bear. Absolutely, we have controls and we layer them, and that's what you do as architects, and that's what you do in your software already. When you're building software, you're building functional chains of bits of code that solve problems. Security is just another set of problems. So, you may have heard a term around the place a lot called zero trust. It's been popping up all over security for a while. Raise your hand if that is a concept that you've come across before. Yeah, about half of you, give or take. Now, zero trust is a very buzzy marketing term, so we can sort of ignore all of that rubbish. It's not something you buy in a box. It's not something that's going to save the world. But zero trust is a concept, essentially, of assuming compromise, assuming that nothing in your ecosystem, in your network, in your architecture can be trusted. And so instead of debating whether you should or shouldn't monitor or shouldn't put some controls in, you put the controls in. You look at every component, every interaction that's happening, and you choose the controls that are going to help you prevent or reduce the likelihood of a bad thing happening, detect it if it does, and respond quickly and limit the impact in the event of the bad thing. So it's all about controls. It's about this. It's about layering these. And as software architects now, your job is to not just employ, oh, well, I'm going to use this bit of functionality here or this library to do this to get the job done. Functionality-wise is also to figure out which security controls you need to put through your architecture to help protect against bears or politically motivated people or financially motivated people or people who just really don't like you or people who have no idea who you are but they figured out that you used AWS and it was a cheap shot. So these are the things that you need to start playing around with. And some of them you will have played around with and not really realized. And some of them you might misuse the terminology a little bit, because we all do. But this is where we start. We don't start with a grand scheme of, I'm going to reinvent the entire internet. We learn about one control at a time and see what it means to us. Now, if you don't want to do all of this from scratch, there's even some nice guidance that you can use that can help you out. So this picture here is from an OWASP project that you've probably never heard of. It is the Threat Modeling Cookbook. It is an open source set of pre-made threat models. There's textual ones, visual ones. The idea of these is they are predefined architectural designs that you can look at and understand where security would need to fit. Now, the one I've chosen here is a payments platform. Now, are you likely to build a payments platform from end to end? No, but many of us integrate with them. You go and use Stripe or Chargebee or whatever it is you're doing. So these reusable patterns help us to learn the muscle memory, if you will, of placing these controls in our systems. There's some more bits of the OWASP world I would love for you to go and see. There's OWASP Threat Dragon, which is a tool for modeling your architecture. Now, if you already use Miro or Lucidchart and you're already kind of cool with diagrams, don't stress the tooling too much in threat modeling. But if you're looking for something that can do it all end to end, then have a play. The threat modeling cookbook that I just showed you has the diagrams. The threat modeling manifesto teaches you about what is going on in threat modeling, why it's important. And my favorite one of this list is the awesome threat modeling. If you just literally Google that phrase, it's a GitHub repo, and it is training courses, guides, cheat sheets. It is a massive GitHub list of everything you need to get started with threat modeling. Now, if you want to think about what a threat model is, imagine you ran a bank. Your threat model is looking at one of the systems and trying to figure out how you would rob that bank. Have any of you ever planned a bank robbery before? No? Ever planned robbing your current employer? Nope. Look, thinking about crime does not make you a criminal. Threat modeling is essentially thinking about crime. And one of the big blind spots we have, talking about those blind spots from earlier, is that we feel awkward and slightly uncomfortable and nervous when we say, hey, you should really think about how you do that, because if you don't think about it, the attacker's not shy or nervous. Now, I'm not going to ask you how would you steal your neighbor's wallet. That's a little bit intrusive. But thinking about your world, if you went back to your desk and looked at what data you had access to or what's the worst you could do with it, that gives you a step up when it comes to understanding how you protect it. So at the design stage of our life cycle, here's your homework. I am that speaker. And none of you will do it, but maybe you'll remember it one day. Your action is to go and draw a system design. Now, I do not mean go and buy a Visio license. Nobody needs to do that, ever. Go and draw on a nice piece of paper like this, or on a whiteboard, or with crayons. I do not care. But draw what your system looks like. And it can be ugly and glorious and incorrect and full of corrections, and that's fine. And then I want you to do a threat model. And that threat model, in essence, is you're going to look at that design and say, if I went evil right now, what would I do to steal money? What would I do to impress my friends? And I want you to practice that skill. Because if all of our teams did that, it'd be much, much harder for the people who do those kind of things because they really want to attack you. Because we'll be prepared. So next up, code. Now, I'm only going to spend a little bit of time here because you already do a lot of this, kind of, really. How many of you do the OWASP top 10 type things and you're like, yeah, I'm super confident with this? Yeah. Do you know, we've been talking about OWASP top 10 now since 2003, and I'm really sorry on behalf of my entire industry. Like, we keep telling you OWASP top 10, OWASP top 10, without looking back and saying it's been freaking 20 years, and we still haven't communicated this right. So, sorry about that. OWASP top 10 is important. Please do and go look at it if you haven't. I'm not going to go into that today, but Troy Hunt has a million talks on it. So go and look at Troy Hunt's video collection. You'll be fine. Yesterday I showed you this. This is Anvanka. This is a model of the NPM ecosystem, specifically the Browserify module and what it connects to. And yesterday I talked to you about transitive risk, about the risk you inherit from other applications that you use and other dependencies in your chain. So I want to give you some really practical steps about how you can now reduce this risk a little bit. Yesterday was the high level, today's the practical. So this is our ecosystems right now. So this tells us how many packages are in each one. Now, raise your hand if you can see the language you write in. Your package manager is on that board. Yeah? Anyone who's like, no, I write in a crazy hipster language nobody's ever heard of. Or C++, that's a valid choice too. No, okay, good, we're all covered. Fabulous. The reason I'm asking is because you need to pay attention to the following thing. Look at your repo, the one specifically for your world. I want you to pick it out. You all got it? It's like pick a card, any card. Right. Now, is your number higher or lower than NPM? Lower. Most of you lower. Great, that's good. Unless you picked NPM, and then sucks to be you. Why does that matter? If your number is lower, when I give you the following instructions in the next few slides, the review stage is going to be bigger, but the upfront stage is going to be smaller. If your number is higher, the review stage will be tiny, but the upfront is much more, and you'll understand this in a second. Because the number of packages in an ecosystem doesn't determine if it's good or bad. It just talks about how big each package is. They all do the same combined thing, They all provide the same functionality as each other, just one of it does it in 50 million parts, and one of it does it in 3 giant parts. So, you know, same difference. Now, this is a GitHub repo. It's one I pulled fairly randomly. Well, I sort of Googled for open source cryptocurrency, because what could possibly go wrong? Now, we're going to pretend as a team right now that we need to decide if we're going to use this library in our platform. Because for some reason, whatever you do, you now need a cryptocurrency platform. Great work. OK, so what bit of the screen are you looking at when you make these decisions? Modified date, absolutely. Cool. What else? Stars. Stars. Everyone says stars. Raise your hand if you use the stars as a good measure. I'm going to one day do a survey on stars. You're not right or wrong. But for me, I think I might just use stars wrong. Because the star for me is, this is funny. And what on earth is this? And I need to show my friend. It's kind of like my like button, but not always for the right reasons. So like when I see 100 stars, I'm like, yeah, awesome. Lots of people thought that was funny too. What else do we look at? A lot of forks. Is a lot of forks good or bad? In cryptocurrency? Yeah, I'd imagine so. Especially if you look at transitive risk and supply chain, it means that, you know, somewhere along the line, there's going to be some really unhappy people. Right, what else? What else do we look at? Number of contributors, absolutely. 1 is a bad number. It's a lonely number. We don't want that because people have holidays and kids and pot plants and soccer teams and things, and eventually lose the will to look after their projects. And then somebody emails them, says, hey, I saw that you haven't contributed in a while, and I really love what you were doing, and I've got some great ideas. Can I have the repo, please? And then they go, yes, here you go. And then NPM was born. We look for the number of contributors to make sure that we have a community, that there's more sets of eyes, that this thing, if it breaks, there's going to be people to fix it with us. What else do we look at? Quality of the README file. Oh, you're better behaved than I am. That's awesome. Anything else? How current? Yeah? Issues. I love reading the issues. Absolutely love it. It's like a soap opera. You absolutely want to be reading the issues. If there's no episodes, then it's not a good one. You've got to have lots of episodes, and they've got to be like sequential. There's got to be drama. Not the bad, toxic drama, but a little bit of discussion is healthy. You want to see that there. It means people are actually debating the right way to do things. Now, I want you to be really, really honest, knowing that you know all of the things you're supposed to look at every single time that you pick out a library, and we all know academically what that list was. Raise your hand if maybe at least once in your career you've just gone, well, it does the job, I'll do the rest of that looking stuff later, and just used it. The rest of you are liars. Now, here's my action for you from this section. I have built you a little checklist, and there is even a nice PDF version I will share via my Twitter a bit later, that is the minimum viable questions you need to ask about a project before you start using it. Now, notice it doesn't say how many stars are on it. It asks you, is it using a suitable license? Now, here's a trick for you if you want to like shortcut all security. Forget security for a second. If it's using the wrong license, stop. Do not pass go. Stop your review. You failed. Move on. Because the license means lawyers gets involved. And the second a lawyer is involved, it doesn't matter about security. The lawyer wins. So if it's using a suitable license, continue. Is it regularly released and governed by a suitable group of people? Are they active in resolving issues? Have you looked at the code? If you do that whole looking at library code, it's helpful. If you don't want to do the looking at library code because you're in Maven or NuGet and your library code is massive and you know it's going to take you weeks to review it, at least run a linter over it. Now, a linter isn't going to find you security bugs, but it will show you whether the code has been kind of disciplined in the way it's put together. It's going to show you those code smells you wouldn't accept in your own team. Remember, this code is part of your world now. So accepting it into your life is like saying, I accept your pull request, and you can come and be in part of my system. So run the same checks you would do on code you want to bring in. Would you sign off on it if it was put in front of you as a pull request? This quality of code, this style, this project. And finally, is the package and version, does it have any security vulnerabilities? Now, I'm going to show you in the next section how you can do that automatically. Alternatively, you can look at things like CVE details or NISTs, the National Institute of Standards and Technology, and they will give you guides as to what has been seen before. Now, remember, those guides are not a guarantee. You cannot look at them and go, well, it's not here, and therefore it's guaranteed to have no security vulnerabilities. It's like testing. Testing cannot prove the absence of bugs. It can only prove the bugs it finds. So looking at those things is a good start. So that's your action for your second phase of your life cycle. It's really late in the day. I apologize. Numbers are really hard. I didn't hit the button. Good. Right. So second stage, we're going to use that checklist. We're going to make sure our dependencies are good. Now, if you have a few dependencies already, and maybe you haven't done this process before, then each time you update one now, just have a quick cursory check. I'm not going to say you're going to rewrite your code, but at least be aware which one is going to bite you first. Right, so testing. Raise your hand if you love testing. Oh, team, I love you. You lot are awesome. Good for you. I love testing. Testing is a freaking superpower. Testing is the reason you don't rewrite code, because you're a tiny unit test at the start, and you prove or disprove your test, job done. I like testing because it makes my world a bit more binary. Black or white, pass, fail, red, blue, I do not care. It is on or off, it's broken or it's working. Now, that's just how my brain works. The testing in security is a real superpower. Now, raise your hand if you still measure code coverage in your testing and celebrate it. Any of you still doing that? Yeah? Okay, cool. Gonna kind of shift you away from that a little bit. It's not that it's a bad thing. It's just that it's not telling us the story we want. So what I'm going to ask you to do for security's sake in your testing stage is to move away from test coverage as being your leading indicator of quality of code. So test coverage tells us, have we hit every line of code? It doesn't tell us, have we tested every potential pathway and story that's possible with this code? Now, do you remember that threat assessment at the start where I told you to rob a bank? No, plan a bank robbery. I'll be very specific. Don't rob the bank, plan it. That threat assessment will give you a list of the scenarios that somebody with a bad intention or a different motivation than the one you originally planned would try and use in your system. Your testing can model all of those pathways, all of those likely use cases, and use it to say, hey, would the bad thing work? Now, you'll notice I'm not saying go test for SQL injection and all that kind of thing. I'll come to how you can shortcut that and cheat a little bit in a minute. But when it comes to the real manual effort testing, the stuff you're going to spend your brain power and your hours on, I want you to explore. I want you to link your testing to your threat model, and I want you to play. I want you to look at your custom-built application for the management of garden gnomes, or whatever it is you do, and they pay you to do it, and figure out what's the worst that could happen? What would that look like as an attack? And can I write a test that would try and do just that? And even just a few of those tests would put you far ahead of most other teams globally. And it's fun. It really is. Now, if you're like me and quite lazy, I am very, very, very lazy, or efficient, as I like to say, in performance reviews, there are two other things that you can start looking at. The first is vulnerability scanning. Now, in human terms, a vulnerability scan is kind of like if you went to Briscoe's and they checked your temperature on the way into the store. Now, is that going to tell you if you have X, Y, or Z nasty, horrible disease? No, but if your temperature is high, it's probably a sign something bad is going on. Automated testing or more sophisticated testing, things like penetration testing that you may have heard of, those are more like doing a specific medical test. It's looking for multiple variables and absolute evidence that you are sick in that particular way. You can tell it's been COVID times. All of my analogies have shifted to health. Sorry about that. I'll shift back to sports soon, I promise. You can look at both of these. Now, I'm going to try and do something. It could go horribly wrong. And if it does, you can just smile and clap anyway, and then we'll pretend that it was all fine. Oh, look at that. Oh, it came, it happened. Oh, all right. So this is OWASP. Now, there are many vulnerability scanning and testing tools out there, dozens of them. I've intentionally chosen a free open source one that you can download and get gone with no time at all. Yes, I checked the signature on it. Yes, absolutely. Yes, I did. But thank you. I'm glad you caught me up on that. I'll get my prize later. Now, this is an ugly Java application. I'm not going to make any excuses for this. This is like the peak of Java Swing. But what it can give you is the ability to, in that nice little box there, point it at an application and hit a button marked attack. And at your peak laziness, you're going to do the worst, noisiest, low-hanging fruit security testing of your life. But it's probably the most security testing you'll have done in your life too. So you've got to start somewhere. Now, this is a really powerful tool. I'm not going to demo all of it today. I am going to give you the following disclosures. Please do not point this tool at sites you do not have prior written consent to point it at. That is computer crime, and you do go to prison for that. But you can point this at your test environments. You can point it at localhost. So you can run your local apps in a Docker container if you like, and just point it at your container. Off you go. And what that's going to give you is the ability to run something, get some results, and at least think about what's going on. This tool will also let you log in. It will let you map flows through it. It will let you repeat requests and proxy them, much like things like Postman and all of those will do. But it's specifically designed to find common security vulnerabilities. So there you go. In your testing stage, you can now do some exploratory play, and you can hit a massive button with a lightning on it that says attack and do really, truly terrible security testing, but at least you've started. Now, if you want to take it the next level and you're like, oh, this is cool, I like this, we can do this, I might even pass a performance review, then you can run this in headless mode. And you can write Cucumber-based tests, automation tests, the same way you would do in many automation testing frameworks. And you can then hook into this and call the specific attacks one by one. So that could be really great if you wanted to put it as part of an automated testing framework, if you wanted to move up to the fact that eventually you put it in your CI/CD. But take it maturity by maturity. We started today in this room not doing a lot. We're not aiming to get super mature DevOps 2%. We're aiming to be a little bit better than yesterday. Now, when you're putting your testing in place, if I get rid of that so you can see the right screen. Go on, Java. It's time for you to go to sleep now. All right, good. When you are doing your testing, a little bit of a word from not the wise, but the person who's got it wrong many, many times. Please remember that security testing tools are not the most efficient, scalable, or performant software on the planet. They never have been. They're written by people who have really good intentions, but haven't been doing the type of software you've been doing for your whole career. Manual ones, you run outside. Some of them will take hours to run. It's why I'm not doing an OWASP scan here, because the sites that I would put it against safely to this audience, it's going to take 25 minutes. And for me to go, ta-da, after 25 minutes is a waste of everyone's time. So running the manual's fine, but allow that time to get the results in and then process. If you can't put them in your CI/CD pipeline because they are too slow, because your pipeline currently takes 6 minutes to run and 6 hours is going to make some people upset, then consider having a parallel pipeline, so something that doesn't run on every commit or every build. Maybe it runs on a cron job or once a week or once a month. And that's not that bad, actually, just because it isn't every build. Because remember, when you run a security tool, you've got to do something with the results afterwards. So if it runs every build and you've got no time to fix it, then all you're going to do is cry. So you're much better to have a parallel pipeline that runs on a different frequency and allow some time in your sprint to then rectify before you run it again. So some action for you on this one. Stop considering your test coverage. It's great. I love it. But it's not a leading indicator. It can't tell you what's coming. It can only tell you what's been. And it doesn't test all of the pathways that your code is likely to be used in. It just tells you which bits of your code have been tested. And I want you to allow more time for exploratory testing and play. Now, some people call this hackathons and bug contests and things. I don't care. Call it play. Be the group that says it's OK to find a button on a counter that says lift and grind and make it super safe for the team to go, what if I press it twice? Do I lift then grind? Does it grind then lift? If you are too scared as a team to play like that, then you will always be at a disadvantage in security. So let's get into deploy. Don't worry, we're going to be on time. I like robots. You may have guessed that yesterday. Robots are a superpower in deployment. I'm going to show you some really quick things you can put into your pipelines right now with no fuss at all and just do security. The best kind of security you see is security that you don't have to remember to do. Fantastic. So this is a set it up once and then profit sort of situation. Okay, so demo. Whew. All right, wish me luck, team. I don't do live demos. I don't know why I decided today was the day. But all right, let's go for this. All right. Ooh, where's my mouse? Come back, mouse. Oh, there it is. Okay, we'll move you over there. Not only do I not like demos, but I switched to a Mac for the first time in a decade 3 weeks ago. This is just like stupid levels of masochism. Right, okay, so this is a terrible repo. It's an open source repo I wrote in 2014. I haven't even dressed anything up for you today. I was like, if I'm going to run security tools on a repo that's never done security before, I'm going to pick a good one that's truly a mess. Now this one, it generates a fake Active Directory domain filled with Marvel Universe characters, because for reasons in 2014 I needed to do that. Okay, so would you like to see how we're going to get some security going on with very little stress at all? Fabulous, good. Now, first thing I'm going to do is I'm going to jump to a command line. Now, where do we not put secrets? Who can remind me? In your source control. Absolutely. Good. Well done. Let's see if I can get that to go over there. Is it going to go over there? Oh, I shouldn't have maximized it. I've made mistakes. All right, we can do this. All right, there we go. Okay, we'll move this over here. Right, there is a tool. It is free. There are many tools like it, but this one is free. It's called Truffle Hog, like the small pigs that find truffles in orchards and things. And its job is to sneak in and find if there are any secrets in your GitHub repo. Now, at the easiest, low level, I have no automation skills and I don't want to learn anything. You can run it at a command line like this. Trufflehog, space git, and the name of the GitHub repo. And then you press enter. It's a very good demo. Then it thinks about it. There it goes. Okay, so it runs, and then it finds GitHub keys and GitLab keys and passwords and OpenSSH keys. Now, some of it will verify, and they'll go green, and some of it will be like, I'm not sure, and you should just investigate. Now, who thinks it's a good idea that you run a tool that literally just needs you to press one finger on a button to do security? Fabulous. Okay, you can get Trufflehog and you do it today. Now, even nicer than that, because who needs to do things at the command line when we have GitHub to do it for us, is if I pop over here to TruffleSec's webpage, they're super, super nice on their docs. Now look at this. They've provided a GitHub Action, and they can get it to run automatically on every single build. Fantastic. Raise your hand if you've never set up a GitHub Action before. Okay, a few of you. That's cool. We'll do it together. Why not? Let's do that. So we'll go back to our terrible, terrible repo. Let's close those all down. We don't need them. Bye. All right. Actions. Whew. All right. Okay. So what we're going to do is you just do a new workflow in Actions. Now, you can either choose a workflow, so there's lots of pre-made ones available, or you can set up a workflow yourself. Oh, there we go. All right, cool. Even I can do this. I am the most terrible, unenthusiastic demo person you will ever meet. We can do it, team. All right, cool. All right, job done. See the speed typing I did? It was flashy. Done. Done. Now, that wasn't really useful to you as a demo. None of these demos really are. The whole point of this, though, is a GitHub action, every time I do a commit, is now going to run Trufflehog, which means before, it's a pre-commit hook. So before the commit actually hits the repo, it's going to tell me, is there a bad thing in this repo, and should I do something about it? Now, what does this mean? It means our secrets don't get into our repositories, and secrets that aren't in our repositories can't be stolen. They don't need to be rolled or replaced. And it doesn't matter when, team members leave and things. We've got a lot more control. Now, even better than this is instead of them being in your repo, where should your secrets be held? Post it on the wall is not the answer. No, do you want to see in GitHub? I don't know if any of you have played with this, so I'll just show you very quickly. Settings. Now, there are vaults of all kinds. Vaults like HashiCorp Vault. There's one built into Azure. There's one built into AWS. And in GitHub, even in GitHub, you can set a safe place that stores your secrets encrypted. It takes less than 2 minutes to set one up. You just go new secret. You put a name, and you put the secret, and you add, and that is it. And then if you want to look, I'll show you an action I created earlier. So we've got the one we just done, and that's one I created earlier. So if I show you the actual code for this, they live in your GitHub, in your repo there. There we go. So semgrep.yaml. Now, semgrep is the second tool I would love you to consider putting as an action. If I just show you what that is over here. Semgrep is a free security static analysis tool. So it will run a whole bunch of security static analysis checks over your code. There is a free edition for up to 20 developers, and there are many other free versions of tools that do a similar thing. And you can run it from the browser like this, and it will just run on your things and give you little reports and send you emails. So I can go into Marvelous Log, which is the one that we did earlier. No issues, fabulous. That's because it's really, truly terrible tiny code. And you can kind of look into what it's done. But if we go back into our GitHub Actions, we can get it to run that exact set of scanning tools on every commit as well. Now, that's going to tell you things like common signs of SQL injection, of cross-site scripting, all of those things you don't want to get into your repo. Now, having as a pre-commit hook means that before you build, before you deploy, before it gets messy and into your world, you're going to be able to flag that and bring it up. OK, so it's a very practical thing you can do today. Semgrep has really great documentation on how to build this. I built it earlier. It did take me about 3 minutes end to end. And the hardest bit was making sure I didn't misspell the variable name here for that secret. Because you just add the secrets like you would in any other code base, just as a pass-through variable, so that we haven't got it hard-coded in the repo. And then every time you do a commit, you go into your actions, and you're going to see the results of them here. So this is when it ran. And you can dig into the scan itself, and you can see all of the tasks it did. And you can actually dig into each and every one of these and actually look at the command line and all of the output. That's really, really useful instead of having to have a separate box that's doing it for you. OK, cool. We're running out of time, so I'm going to move onwards. So our actions from this section. Oh, hello, terminal. I don't need you anymore. Oh, actions from this section. I would love you, if you're in GitHub land, to set up some basic GitHub security actions. So aim for Trufflehog, aim for semgrep. If you are not in GitHub, don't feel left out. You can do similar things in Circle CI and in GitLab. It's just easier for me to pick one and demonstrate it. So run the tools manually first from your command line. It's normally 2 lines to install them using Brew or your equivalent package manager. Set up your GitHub Actions, set up a secret and store it in your GitHub in a safe way, and then have a go. The other one you want to check in your GitHub setup, if you are using GitHub, is in the suggested security actions as Dependabot. Is anyone using Dependabot already? Dependabot's awesome. It will check all of your third-party dependencies. And if there's a vulnerability in one of them, it's going to alert and break your build, which is good. So turn these things on. No cost, 0 cost so far today. You've not spent a penny. You haven't even spent a lot of time. You've just worked out your finger. Right, so support, final little bit. The most important thing I can tell you today, and that you can go and do for your security, is to do this. Now, this is an airline safety card. This is the New Zealand isolation plan. So if you get COVID, this is what they put in your letterbox. This is an incident response plan. This is what you do when a bad thing happens. And like I said at the start, bad things happening is inevitable. So we just breathe through that decision, and then we make a plan. So the last thing I want you to do to get security all the way through your life cycle is to have an application security specific incident response plan. Now, I'm not talking about ransomware. I'm not talking about dude leaves a laptop on a bus. That's not our world. I want you to look at things like account compromise. I want you to look at, hey, I've had a support ticket that says I can see somebody else's details in my portal. That's not good. The types of scenarios that only really are going to be dealt with by people like you. So having a playbook for this is really important. Now, PagerDuty, the incident response and paging out sort of system, there's probably a better word for that they use. They have some really great open source documents on incident response planning in general. It's not aimed at security, but you can adapt it. In security, our basic incident response plan looks like this. We have identification. Is there a problem? So that could be your support team tells you that there's something mysterious going on. It could be your logs. It could be any other monitoring or alerting you have. Next comes verification. How bad is this problem? Is it really a problem? And how many people does it affect? And how long has it been going on? Now, there's some horrible statistics in security about how long it takes us to notice we've been compromised. It can be over 6 months to notice a compromise, and that's just terrifying. But at this stage, it tells us how much do we need to care, how much is on fire, what's going to be the impact of this. Next up is containment, stop the bad thing happening. So if it was an account compromise, for example, maybe we'd lock that account, stop any more transactions happening. If it's that somebody can see other people's data, we will probably kick everyone out for a second, to be honest, to say, hey, all right, we've got data exposure here. We need to do a bit of an audit here of what data has been exposed, what are our regulatory requirements now, who are the customers involved, so you've really got an idea, and so you can prevent further data leakage. And the best thing you can do in an incident response plan is have lots of playbooks. Now, playbooks are like checklists you would act out in different scenarios. So account compromise might be one of them. Lost AWS key might be another one. I've done that one myself. It's not fun. Remediation is our last step. How do I get things back? How do I fix this? Now, in AppSec, we have some types of incidents that you can't recover from. Everyone says that, you know, if I was an attacker and I got access to a database, maybe I'd just delete the whole database. But why isn't that a very scary attack to me? Backups. Raise your hand if you have backups. Go team. Raise your hand if you've tested your backups. Go team. Less team. The rest of you, go test your backups. They're not backups until you've tested them. OK. We're not scared about database destruction because we can just restore. But what if you had a breach that took 6 months to notice that was a minute change in one financial figure in a table? And that figure had been used for calculations, say, in a bank. Unpicking that is not easy. 6 months of financial aggregation is not something you just go, I'll just roll back. You can't roll back a bank 6 months. So I want you to plan your remediation activities with these kind of scenarios in mind. AppSec incident response is incredibly challenging, but super fun. Now, when you're doing it, I want you to gather the team and do this as a team exercise, because it's going to need all of you. It's going to need that person who is the only one who knows about the database, that person who could actually find you the logs if you needed to. Because you write your plan, and then you test it. You simulate the exercise. Hey, we've had this situation break out. I'm going to need the logs. How many logs do we have? None. I'm going to need other logs. And you go through this finding the bits you don't have, finding the bits that aren't going to work, the assumptions you've made, and then you fix it. So your action from this is to create an incident response plan. Now, that plan could just be 4 boxes at this point that says those things on them, and one playbook where you take the most likely application security breach of the thing you've built, and you write down the steps you would need to check that was an issue, to verify it fully, to contain it to stop the spread, and then remediate and fix it. So just one playbook. Aim for just that. OK. So what we've done is we've taken our code-centric view of the universe, and we've turned it into something that isn't just developers. It's developers, testers, and analysts, and architects. It's the people who use our systems. It's the processes we do before we use third-party components. It's the way we think about how people would attack us. It's given us testing tools that we can test for security things with little to no effort. And then maybe we'll get more mature with time and do something more. We've got GitHub Actions that we can throw into our life cycle so that none of those secrets get in, and that we find those security vulnerabilities with a static analysis tool automatically without having to remember or add new things to our world. Now, I think that's a pretty good place to start. Even if you haven't done any security before, raise your hand if any of that feels achievable. Like, you could go and do some of that. That's what security is. Security isn't some super qualified person in a cape who shows you magic tricks. It's someone who goes, hey, you're engineers, I'm an engineer. Did you know there's this cool thing you could turn on? That's what security is. So be that person in your team. Be the person who looks at the bad things, finds solutions, and get a little bit more secure every day. Now, I mean what I said. I'm trying to spread this message as loudly and clearly as I can around the world, and I give my time and my energy with genuine, free of charge nature. There is no scam here. There is free training on secure development at that barcode, and not Rick Astley, I absolutely promise you. And if it's not for you and your company, because your company already does it, then find the little tiny companies and the little open source projects who have no one to help them, and give them that barcode and show them. Because there are 30 million of us in the world, and right now, less than 1,000 of us identify as security. And only one in this room, and he wasn't even sure. So next time I ask you if you do security, raise your hand loud and proud, and tell me that at least one of those things that you did to secure your life cycle. Thank you so much. If you have any questions, feel free to ask. I'll be around afterwards. I'm me. I'm not hard to spot. Any questions? Oh, the security guy, he's got questions.
Hi. First off, it's painful to see all those free tools because we're paying so much for tools that cost money to do the same thing. But
I'm sorry. There is cake and stuff.
And that makes me feel so much better. But my real question is, I think the challenge that I face mostly is not the intention to do security, is the sort of do I sell it to management? Because it's so hard to get them on board. Like, hey, this thing looks a bit shaky, and I want to spend time or get my team to spend time.
I'm going to push back on the assumption that's based on, and forgive me for doing so. Sorry for the feedback, team. I wear hearing aids, which creates a many microphones problem. So if your code wasn't performing so well and you needed to give it an extra hour or so to figure out that performance issue, would you go and get management's permission?
Never.
No. If it was unusable and the button was in the wrong place and you needed to rejig it because nobody clicked the right button, they all clicked the wrong one, would you go and ask management?
Didn't really hear the question, but I probably wouldn't.
No, absolutely you wouldn't. We don't, for any other measure of quality, go and ask management permission. We just go, screw this, I've got to fix it. So let's stop treating security as something that needs management buy-in, and let's just do it and ask permission, well, no, forgiveness later. That's the one we want, forgiveness. Because realistically, security is part of quality. It is not separate. So I get your pain, and I will talk more lengthily with you afterwards if you'd like. But the cliff notes really does need to be, we need all of us to stop asking if we can do it and just do it. Because they would actually probably most of the time assume you were going to do it anyway. They're only making a decision because you made it optional. Hi. Gentleman at the back with a lovely stripy shirt.
Just following on from that question,
Yes.
actually, is that one of the issues is not so much, yes, we can build security as we're going, but I could literally spend 10 sprints improving the security of the legacy code we've got. Trying to sell that to management is extremely hard.
And legacy projects are their own special challenge for this. Now, what I tend to do is firstly always record your security debt. So even if you can't fix it, because it's going to take 10 sprints, have it written down somewhere close to where you keep all your other debt. But have it flagged as security so that there is a way to report on it. Then I would focus anything that is not a preventative control, so that's going to stop or change code, but detective controls. So detective controls give us the benefit of telling us how frequently is this code used? What is the exposure here? Where is that traffic coming from? And so if you start prioritizing the things you need to address with legacy systems about finding the information of what the risk is first, rather than fixing all of the potential problems, it does allow you to naturally narrow the scope. From there on, the other option is to start segmenting and isolating those systems so that there are additional trust boundaries around them. So that could be access control lists and things. And the same goes for third-party dependencies where we can't change them anymore because they will break everything. You have to kind of say, okay, if I step back from my solution was because I've got vulnerable code that could be accessed. I can't do the typical pathway. What is another way I can solve that problem and compensate?
Sorry, just one more question.
Of course, no.
You mentioned those vulnerability tools. Do you know if they're available in Azure DevOps as well?
Yes, absolutely they are. Now, I'm not an Azure person. I'm cloud agnostic, which means I know very little and can be dangerous in most platforms. But I would say start off firstly getting into Sentinel in Azure, because Sentinel's centralized security console is pretty good. But there is definitely built-in stuff because Azure DevOps is owned by Microsoft, and Microsoft owns GitHub. So if they're not using their own stuff, I would be very, very surprised.
Thank you.
Any other questions?
Just wondering about the Truffle Hog tool, which looked fantastic. If you sort of stubbed out, just for an example, the word password and XXX, which wasn't an actual password, I'm assuming it would pull that one up.
In all honesty, these tools have been maturing quite quickly. I would say it would probably hedge on the unverified, but it would still give you a finding. But in my world, I'd much rather have an unverified finding that was a false positive than no findings because it wasn't sure. So yeah, absolutely. You'd need to try in your code base. And if it wasn't a false positive, because you do have password XXX in your passwords, you've probably got a bigger problem. Anyone else? You've been fabulous and super lovely. This has been great. Thank you so much for your time. I will be just loitering out in the corridor for a little while if you do want to come and have a chat. If not, come check out some training. Go check out Troy's talk at the party tonight. And then you'll be like security all the time. You'll basically be updating your LinkedIn before the end of the conference. Okay. Thank you so much.